Hello friends, welcome back to BitSize Python. My name is Nijat. Today we're going to tackle the LeetCode question number 2, add two numbers. This question is about linked lists and then how to handle carryover values. So I'll walk you through step by step showing you how to keep your solution efficient and clean. By the end of this video, you should be able to handle any linked list addition problem for any coding interviews. So let's get started. I have prepared the workable Jupyter notebook and then provided the GitHub link if you're interested in following along. And then also I have provided the solutions to my Medium account as well if you're interested in reading that solution over for yourself. So let's get started. So LeetCode question number 2, add two numbers. So we're given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and then each of their nodes contain a single digit. And then two numbers and return the sum as, add the two numbers and return the sum as linked list. So for example, input 1 is list 1 is equal to 243, that represents 342, and linked list 2 list has 564, which represents 465, and then the output, the expected output is 708, which represents 807. Everything is reversed. So we're going to talk about linked lists and then pointers and references, how to traverse through linked lists to calculate the sums at each digit. So let's walk through this. I have provided the logic here to solve this problem. So first of all, we're going to create a linked list class and then helper functions. And then step 2 to step 5 is how to solve this problem. Okay, let's create the node class. So a node class has two things in them. So the first one is the value of the node, and then the second thing is the next pointer that is pointing to the next node. For example, if you have a linked list 2 pointing to 4, pointing to 3, and pointing to the next node, the first node is 2, and then the associated next pointer, and then the next node is 4, and then the associated next pointer, and then 3, and it goes on. So let's create this node class. So let's start with the class keyword, and let's call it node. And then let's create the init function for this. It's the initialization function. And then the first argument is always self. And then the two things we have, the first thing is the val is equal to, let's just initialize it as 0 if nothing is given. And then the next pointer, and then let's just call it none. And then self.val equal to val, and self.next equal to next. Okay. So we have created the class called node, and then this node has the value as well as the pointer pointing to the next node. So we're done with creating class node, and then now we're going to create 3 helper functions that will help solving this problem. The first helper function we're going to create is to convert list to a linked list. For example, if we're given 243, we're going to convert that into a linked list 2 pointing to 4, pointing to 3, and pointing to none. Okay, let's create this function, definition to linked, and then we're given a list. So first we're going to create a dummy variable, and then we're going to create this node from the node class we just written. And then we're going to create a pointer. We're going to point this pointer at this dummy variable. Okay, all we're doing here is we created a dummy variable, and then that now is pointing to none because next is pointing to none here. And then we also created a pointer variable that's now pointing to this dummy variable. Okay, now we're ready to traverse the list. So for number in LST, so for each number in this list, we're going to construct our linked list. So the pointer dot next is going to be this node, and then the node has this number that we're traversing through. And then now we're ready to move our pointer to pointer.next. So all we're doing here is initially this is our setup. Dummy is pointing to none, pointer is pointing to dummy. And then for each number in the list, where for example in the first iteration num1 and then its associated pointer to the next one is added, and then after that we are moving the pointer to num1, and then in second iteration we're just adding num2 and its associated pointer to the next, and then we're just updating the pointer. And then in this way we are creating our linked list or linked list in this fashion. And then in the end we are going to return the dummy.next. In the end, In the end, we have to return this linked list that we are creating. So in order to do that, we just return dummy.next. So dummy.next includes from number 1 all the way to none. So in the end, this is what we will construct. So number 1, number 2, and then anything else in this list is going to construct this linked list. So this is how we convert a given list into a linked list. Now we're ready to create our second helper function. The second helper function is to print a linked list. So if we're given a linked list like this, how do we print that out? So definition, so let's just call this print linked. And then we're given a linked list. To represent a linked list, we just need a node. So we're going to give it a node, and then we will just traverse through this linked list from one node and then traverse through it, and then we're going to print that out. So we will use a while loop for this, while node. So if this node, starting from the head, if this node is true, we are going to print the node dot value, the associated value with it, and then let's separate these values using this separator, and we will just use an arrow to separate these different values. And then after that, we're ready to move the node to next node, node.next, so that we can continuously traverse through the node one by one. At the end, when we're done, the last one, when the node is touching this none, let's also do print out this none value as well. So that's all we're going to do to print out this linked list. Okay, so that's the second helper function that we're going to write. The third helper function is to convert a linked list to a list. So if you're given a linked list like this, how do we convert that into a list? So definition, let's just call this toList. We're given a node, and then let's create a list, an empty list to store our values. And then we will do the same logic here. We will traverse through the nodes one by one and then add that to our list. So while node, we're going to lst.append. We're going to append the node.val to this list, and then now we're ready to move the nodes to the next one. Next, and then we're ready now to return our newly constructed list. So now we're ready to, this is the function to convert a given linked list to a list. Okay, cool. So just a quick review. So we've created a node class, and then we've created a function to convert a given list to a linked list. And then we've created a function to print out this linked list. And then we have created another function to convert a given linked list to a list. Now we're ready to test these functions. So we have a list given. List 1 is 243, which represents 342. List 2 is 564, which represents 465. And then we're going to test, first test the toLinked and then printLinked functions here. We'll just give the lists and then print out linked lists. And at the end, we will also test the toList from the converted linked lists. L1 and L2 is given to the toList function to convert them back to the linked lists. Let's just quickly run this. So here it is. So the list 1 is converted to linked list, which is 243, and then that is 243 none. And then the list 2 is converted to 564 none. And the toList function is also tested, and then that's now converted back to list. So everything is working correctly. Now we're ready to solve the problem. Now we're ready to write the function to add the two numbers represented by linked lists. So def, let's call this add two. So linked list 1 and then linked list 2. So those are two linked lists we're going to add. And then we're going to initialize our dummy variable as before, create the new node. And then let's have another variable called pointer. Let's point it to the dummy variable. This is the exact same as before. But here, we will also need a new variable called carry that's going to be initialized at 0. Why do we need this? We need this because if two integers, when we add two integers and then the value is greater than 9, we need this carry variable to track our carry. So now we're ready to go into the loop to go through these digits one by one. So we will use the while loop as usual, and we will look at linked list 1, is it true? Or linked list 2, is there something in there? And then we will also have to look at this carry variable. So we will have this condition. So we will look at linked list 1, and the value, linked list 2, the value, and then also the carry. If any one of these are true, then we're going to get into the loop, and then we will do our calculations. So we will first have to extract the first value from the first linked node. That is, let's call it value 1. And then let's do it L1.val. So that's the value. If L1, so let's quickly check if L1, if the value of the L1 is true, then we're going to extract a value from it. Else, we're just giving it to 0 because there's nothing in there. So val2, we will do the same thing. L2.val, if L2, else, we're going to give it 0. Okay, so we've extracted the two values from the two nodes in this section, part, and then now we're ready to add them together. So total, let's call it total. Total is going to be val1 plus val2 plus carry. So we will add all of these things together, and then that's the total. So now we're ready to update the carry. So carry is equal to total integer division by 10. So for example, if I added 9 plus 7, which is equal to 16, and then if I integer division that into 10, that is going to give me 1. So it's that one part that we are interested in. So that's the carry, right? So we will have to use the integer division here. So now we're ready to create a new node. So let's do our pointer dot next. So that's the next one after the pointer. And then we will create the node with total modulo 10. So what we're doing here is the total modulo 10 is going to give us, for example, if it's 9 plus 7 equal to 16, if it's the same thing, 16 modulo 10 is going to give us 6. So it's the 6th part from the 9 plus 7 that we are interested in keeping. So 6 will be given here, and then that's the new node's value. So now we are ready to go to the next pointer. So pointer is equal to, we will point this to the pointer dot next. So we will traverse, we will move the pointer to the new node that we just created. Okay, so after this point, we are also ready to go to the next, update the L1 and then L2. So if L1, if it's true, if something is in there, we're going to update L1 is equal to L1.next. We will do the same thing, L2 equal to L2.next. So, okay, here, so let's just quickly summarize what we have done so far. So we have extracted the value from value 1, from node 1, put it in val 1, and then the node 2 value val 2, and then we computed a total by adding all of those, and then we updated the carry, and then we created a new node, and then pointed the pointer to the new node that we created with the updated value. And then in the end, we are also updated the L1 and the L2 nodes. So in the end, we have to return what we've just constructed. So return dummy.next. So this statement here is going to return, after all of this, we're going to return the newly constructed linked list after the addition. So we're done now with the whole function of adding two numbers represented by two linked lists. Let's just quickly run this function. So it ran. So now we're ready to test this solution. So here is the input. L1 is 243, L2 is 564. Expected outcome is 708 in a list. So test to add function using result is equal to add to linked list 1, linked list 2, and then these are the print linked we've written before, and then to list we've written before too. Expected result is 708. Let's see if that's the result. Run. Okay, cool. So we printed out the linked lists. So that's the linked list we've just created using the add to function, and then we've converted that into the as a list, so 708. So this result is as expected. So that's the function to solve the add to linked list, add two linked lists. Cool. Let's just quickly summarize and reflect on what we've done. So first of all, why does the solution use a carry variable? So the solution uses a carry variable. So this is the part that I've explained earlier. When we are adding two numbers, if they exceed 9, we need to carry over to trace the carry. Okay, cool. The second one is, how does the solution manage cases where the lists are of different length? So if it's different length, so for example, node 1 has a value, then we use that value. If not, we're just going to give it 0. And then the same as well too, if it's a different length, we're just giving it 0 if that doesn't exist. Cool. The third one, could there be other approaches to solve this problem? So this is up to you, however you might want to do this question. There might be other well-constructed solutions to this problem. If you know any one of those, please let me know in the comment section. I'm always eager to learn new ways to improve the solutions. So I have provided some reflections here as well, that you have also access to this inside this Jupyter Notebook. So that's it for today's LeetCode challenge. Hope that you've learned something, and then if anything, review the linked list data structure. Thank you for watching, and see you in the next video when I tackle LeetCode question number 3. And then please don't forget subscribing.